Okay, here's example 9 of working with the area of regular polygons. In this case, we are given the problem that says area of the regular hexagon is equal to the area of the equilateral triangle whose perimeter is 36 feet. And we are supposed to find the side of the regular hexagon. So the side of the regular hexagon is denoted by the variable x that I already drew out right here. Now, we are given the perimeter of the triangle, which is 36 feet. And since the triangle is equilateral, we can find the value of all three sides of this equilateral triangle by taking the perimeter and divided by the amount of sides that we have. So 36 divided by 3 is going to give us 12 feet. Like that. So we can go ahead and set up the problem as stated right here. So since the areas of both the regular hexagon and equilateral triangles are the same, we are going to set both equations equal to each other. So we got 1/2 times the apothem multiplied by the perimeter of the regular hexagon, not the triangle, and set it equal to the formula for the area of the equilateral triangle. Now in this case, because we found the size of the equilateral triangle, we are supposed to use the version of the formula for the area of the equilateral when we are given the side, which is square root of 304 multiplied by the size raised to the second power. So that's going to be our right hand side, 304 times psi raised to the second power. But we know the side is 12, so just replace the side with 12. Now for the perimeter of the regular hexagon, to find the perimeter of any polygon, just add all the sides together. So we got x plus x all the way around. That's going to give us 6x. So that means we are going to have 1/2 multiplied by the apothem multiplied by 6x. So maybe I should put it like this. There we go. Equal to square root of 3/4 times 12 square. Well, let's see. 12 square is 144. 144 divided by 4 is going to give us 36. So that means we got 1/2 multiplied by the apothem multiply 6x equals to 36 square root of 3. But at the same time, 6x times 1/2 is going to give us just 3x. So this is 3x multiplied by the apothem equal to 36 times square root of 3. And because we are asked to find the side of the regular hexagon, which is denoted by the letter x, we technically have to solve for x now. So we get x by itself by dividing both sides by 3 times the apothem we cancel this out, 3 cancel out, left hand side we're left with just x, and x is going to be equal to, let's see, 36 divided by 3 is going to be 12, so we got 12 times square root of 3 divided by the apothem, which is the apothem, but I'm just going to put apothem instead. Well, we can find the apothem by going back to this figure and sketch it out in the red. So the apothem is the distance between the center to any one of the sides of this regular hexagon. And of course, they intersect perpendicularly, so there's going to be the right angle right there. To find the apothem, it is worthy to cut this hexagon into different triangles like that, and the degrees of all of the angles in all of these triangles is going to be 60 all the way through, because if we take one point, we go all the way around, that's going to be 360 degrees total. And because this polygon is a regular hexagon, we get to go ahead and take the total degree, which is 360, and divide it by the amount of angles that I'm drawing right now, which is 6 of them. So 360 divided by 6 is going to give us 60 degrees for each of these triangles. Well, by the alternate interior angle theorem, if this angle is 60, then this one is also 60. If this is 60, this one is also 60. If this is 60, this one is 60. And this is 60, this one is 60. Like that. And of course, in this triangle, since 2 of the 3 angles are 60 degrees by the triangle angle sum theorem, the leftover right here has to be 60 degrees as well, because remember that the triangle angle sum theorem says that in any triangle of any type, all 3 angles of that triangle must have the sum 180 degrees in any type of triangle. So using the same reasons, we know this angle is going to be 60, 60, 60 right here, and all the way to all of the other one. All right, oops, and this is also 60 degree right here. So to find the apothem, let's consider the bottom green triangle, and let's draw a separate picture on the side. So I'm gonna draw it right here, and I'm gonna pick the left half of this bottom green triangle. So it looks something like this. This is 90, this angle is 60, because this angle is the same as this one. So with 60 and 90, we know this one is going to be 30. By the 30, 60, 90 triangle theorem, opposite to 60 degree is the short leg denoted by a variable called W. Opposite to 60 degree is the long leg, which is the apothem in the red. It is denoted by the formula W times square root of 3. Opposite to 90 degree is the hypotenuse in the green. It is denoted by the formula 2 times W. But W here is actually half of this side of the regular hexagon. So really W is equals to x over 2. Well, W is x over 2, then we know the apothem is going to be x over 2 equal to square root of 3. And this is what we are going to replace the apothem right here with. So x is equals to 12 times square root of 3 divided by x over 2 times square root of 3. By moving this denominator up to this numerator, we are going to have 12 times square root of 3 over 2x times square root of 3. Square root of 3 cancel out. 12 divided by 2 is going to be 6. So we get x equal to 6 over x. We get a variable on the left-hand side and the right-hand side. So I'm going to move every variable to the left by multiplying both sides by this x. This x cancel out. We're left with just x squared equal to 6. Get x by itself by getting rid of this exponential power 2 by taking the square root of both sides. We're left with just x equal to square root of 6 feet. I think that's a unit. Yeah, feet. So the side of this regular hexagon is square root of 6 feet. Just like that. And that's how we do this problem.